So welcome to Sotantra education. In this lecture we are going to discuss about the concept of recursion. So assume presently you are at your college campus. So I am writing here. Presently you are at your college campus and you want to move to an unknown place. For example, assume some restaurant or assume like you can consider railway station. Everyone know. So assume you are at college campus and you want to move or you want to go to the railway station to take a train or to receive someone like that for any reason, and you don't know the path from this college campus to railway station. You don't know what is the path or what is the route, how to move from college campus to railway station. You don't know. Then in this scenario you can ask someone that please tell me what is the path from this campus to the railway station or from my current location to the railway station. And so let me write this one like this. So you can ask someone what is the path from college campus to railway station. So in short I am writing what is the path from C to R. Then the person may suggest you that move in this direction, turn left, like that. So following the instruction you can move up to 100 meter, 200 meter or 300 meter, or you can assume you can move some distance, and when you face any difficulties then again you can ask someone what is the path from the current location to the railway station. So again you are going to ask someone that what is the path from the current location to the railway station, not from the college campus to the railway station, because you have moved some distance like 200 meter or 500 meter. So let me write this in this way. So you can move from this C to the location L0 and ask the stranger what is the path or what is the path from L0 to R. Here we are going to ask what is the path from the current location L0 to R, not C to R. Now here you can observe that this path L0 to R is simpler or shorter than the original path C to R. Similarly, following the direction or following the instruction of the person, we can move from L0 to 200 meter, 300 meter like this to another place L1, and again when we face difficulties at L1 we can ask someone what is the path from my current location to the railway station, or we can simply write what is the path from L1 to the railway station R. So we can move from L0 to L1, then again ask what is the path from L1 to R. Similarly, we can move to another location and we can ask what is the path from L2 to R, like this. So following the same procedure we can reach the destination, or we can say reach the railway station. So we can write these things like this. So initially we ask what is the path from the college campus to railway station, then we can move from C to location L0 and again ask what is the path from L0 to the railway station, and from here we can move to L1 and again ask what is the path from L1 to the railway station, and here we can move from L1 to L2. Then you can again ask what is the path from the current location or from L2 to R, and following this we can reach the destination. So here you can observe in each step the problem is divided into two pieces or two parts. So here you can observe in each step the problem is divided into two pieces or two parts, a piece in which the result is known and another piece in which the result is unknown. So here you can see initially our problem was the path from C to R. Now we divide this problem into two parts. One is from C to L0, that the path is known, and another one is L0 to R, it is unknown. Now again this L0 to R is divided into two parts. One is known, that is L0 to L1, and the next one is L1 to R, that is unknown. Again this L1 to R problem is divided into two parts. One is L1 to L2, that is known, and another one is L2 to R, that is unknown. So in each step the problem is divided into two pieces or two parts. The first part or the one piece in which the result is known, and the second one in which we don't know the result. So this sub problem, you can observe this sub problem, that another piece in which the result is unknown, is essentially same as the original problem. So it is same as the original problem, but it is smaller or simpler than the input. It is smaller, or we can say it is simpler than the original problem. And gradually these sub problems become smaller and smaller, that results to reach the destination. So you can consider another example like this. So imagine you have a ladder and you can climb the ladder by taking one or two steps at a time. So consider we have a ladder like this, and you can climb the ladder by taking one step or two steps at a time. So the task is to count the number of distinct ways you can climb to the top of the ladder. So you want to count the distinct ways, the number of distinct ways you can climb to the top of the ladder. Now assume the number of steps in the ladder is 1. So consider we have only one step. We have only one step in the ladder, and assume this is the one step, and name this step as A. Then in how many ways you can climb the ladder? So there is only one way to climb the ladder. So you can climb only one step at a time and reach A. Now consider the ladder has two steps and name these A and B. So the number of ways to reach the top, or how many ways you can climb the ladder, is like this. So you can take one step at a time, so 1 plus 1, or you can take two steps at a time. So here we have two ways to climb the ladder. So either you can take one step A, then one step to B and reach B or reach at the top, or at a time you can take two steps, because one step and two step are permissible. You can either climb one step at a time or two step at a time. You cannot climb 3 step, 4 step at a time, like that. Now consider the ladder has 3 steps, and assume this is A, B and C. So in how many ways you can climb the ladder? So it is like one step at a time. So 1 plus 1 plus 1, you can reach C. Then first one step, then 2 step, it is allowed. So first 2 step, then 1 step, it is also allowed. So we have 3 different ways to climb the ladder or to reach at the top. Now consider the ladder has 4 steps. So like this, 1, 2, 3, 4. So assume the ladder has 4 steps and like A, B, C, D. Then how many ways you can climb the ladder, or how many ways you can reach at the top? So you can take one step at a time. So 1 plus 1 plus 1. So total 4 steps. So you can take one step at a time. Then another option is you can take 2 steps at a time. So by taking 2 steps twice, you can reach at the top. Or you can write in this way, or you can climb in this way, like this, 1 plus 1 then 2. So first 1 step, then 1 step, then 2 step. Or you can write first 1 step, then 2, then 1. Or like this, first 2 step, then 1 step, then 1 step. So these are the possible alternative. Or we can write, we have 5 different ways to climb the ladder. So consider the ladder has 5 steps. So this is name this A, B, C, D, E. So assume the ladder has 5 steps. So the number of ways to reach the top is like this. So you can write 1 plus 1 plus 1 plus 1 plus 1. So one step at a time. Or you can write first 2 steps, then 1 step. Or first 1 step, then 2 step. Or first 2 step, then 1 step, then 2 step. Or first 1 step, first 1 step, 3 step, then 2 step. Or you can write first 1 step twice, then 2 step once, then 1. Or you can write this one, 1 plus 2 plus 1 plus 1. Or you can write in this way, first 2 step, then 1, then 1, then 1. Then how many ways we can reach at the top, like this, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 ways to climb the ladder or to reach at the top. So here we can see the number of ways to reach E or to reach at the top here in this example is the sum of the ways you can reach D and the ways you can reach C. So I am repeating once again. So here you can observe the number of ways to reach E is the sum of the ways you can reach D and the ways you can reach C. So we can write this like this. So the number of ways we can reach at step E here in this example is equal to the number of ways we can reach D plus the number of ways we can reach C. So reach E is equal to reach D plus reach C. So if we write in terms of number of steps, so we can write like this: reach 5 equal to reach 4 plus reach 3. Similarly, we can write reach 4 equal to reach 3 plus reach 2. So here you can observe, when the ladder has 4 steps, we have 5 different ways to climb, and it is same as 2 plus 3. 2 plus 3 means 2 is the number of ways when the ladder has 2 steps, and 3 is the number of ways when the ladder has 3 steps. So similarly, I can write reach 3 equal to reach 2 plus reach 1. And when the ladder has only one step, then we can climb this only one way. And when the ladder has 2 steps, we can climb that in 2 ways, in 2 different ways. Okay. So if reach is a method, we can write like this: public static int reach int n, where n is the number of steps. So here we can write, if n equal to 1, return 1. That means when the number of step is 1, then there is only one way to climb the ladder. Else if n equal to 2, then return 2, because when the number of step is 2, then we can climb the ladder in 2 different ways, like here we have discussed this one. And for other values of n, we can write else return reach n minus 1 plus reach n minus 2, like we have discussed this one. So when it is 4, so reach 3 plus 2. When it is 3, 2 plus 1. And when it is 2, so it is only 2 we know. When it is 1, only 1 we know. So we have generalized this and written for n. So when the ladder has n step, and if the value of n equal to 1, return 1, and if the value of n equal to 2, return 2, else return reach n minus 1, reach n minus 2. So here you can observe, this is the body of the reach method. This one is the body of the reach method here, from this opening curly braces to this end curly braces. And here we are writing the reach method inside the body of the reach method. So here this is the body of the reach method, and inside the body we are writing the reach method. Or we can say we are calling the reach method inside the body of the reach method. Or you can say like this: the reach method is called inside the definition of the reach method. Or we can say reach method calls the reach method or reach method calls itself. So when one method calls itself, then that method is called as recursive method, and here this reach method is a recursive method. Here reach method is recursive method. Because this reach method calls itself, or you can say inside this reach method we are calling the reach method. That's why this reach method is called as recursive method. And this concept in programming is known as recursion. And this concept is known as recursion. So now consider another example of recursion. So before moving to that, you can write this one, you can observe this one, the complete program. So the complete method. So public static int reach int n, if n equal to 1 return 1, else if n equal to 2 return 2, else return reach n minus 1 plus reach n minus 2. Now consider another example of recursion. So the factorial of a positive integer n is written as n factorial, and it is equal to n multiplication n minus 1 multiplication n minus 2 multiplication n minus 3, like this it is going to continue, multiplication 3 multiplication 2 multiplication 1. So n factorial equal to n into n minus 1 into n minus 2 into n minus 3, like this, 3 2 1. We know this formula to compute the factorial of any number. So following this we can write 5 factorial is equal to 5 multiplication 4 multiplication 3 multiplication 2 multiplication 1. So we can write like this, 4 factorial equal to 4 multiplication 3 multiplication 2 multiplication 1. So similarly we can write 3 factorial equal to 3 multiplication 2 multiplication 1. Similarly we can write 2 factorial equal to 2 multiplication 1 and 1 factorial is equal to 1. So here you can observe 1 factorial is 1. So 2 factorial is equal to 2 multiplication 1. So I can write like this, 2 into 1 factorial. Similarly 2 factorial is equal to 2 into 1. So I can write like this, 3 into 2 factorial. Similarly 4 factorial is 4 3 2 1. So here 4 3 2 1, I can write 5 factorial equal to 5 into 4 factorial, and 3 2 1 is the 3 factorial. So I can write like this, 4 into 3 factorial. So following this, for any number n factorial we can write n multiplication n minus 1 factorial. So thus the problem of computing n factorial can be reduced to computing n minus 1 factorial. So if you want to write a method for this, and assume the method is factorial of n. So the method name is factorial n, that is going to compute n factorial. So we can write like this, public static. So here I am writing long because the return type of factorial is long, or you can write int, no issues. Factorial int n. So here if the value of n is equal to 1, then return 1. Here we know when the value of n is 1, it is going to return 1. Otherwise, for any other value of n, when it is 2, we can write 2 into 1 factorial. So when it is 3, we can write 3 into 2 factorial. When it is 4, we can write 4 into 3 factorial. When it is 5, we can write 5 into 4 factorial. So except n, for any other values, we can write in the else part return n into factorial n minus 1. So here you can observe this is the body of the factorial method, and inside the body of the factorial method we are calling the factorial method again here, factorial of n minus 1. The factorial method calls itself. So this is a recursive method, or factorial is recursive, and here this one, if n equal to 1 return 1, that means in this case we know the result. So when the value of n is 1, the factorial value of 1 is 1. So it is called as base case. That means we know the result, and here we are calling the factorial method again. So this part. So here it is called as recursive call. Recursive call. We are calling the factorial with a smaller values of n. So here you can observe the method. So public static long factorial int n, if n equal to 1 return 1, else return n into factorial n minus 1. So the method that we have just discussed. So now we are going to see how does the recursion work. Consider a small value of n here in this example. So for simplicity we are taking a small value, otherwise you can take any value of n. So assume n is equal to 4. Now we will see how this factorial 4 is going to work in the background. So factorial 4, so when we call this method, here n value is 4. So if n equal to 1, it is false. So the else part is going to execute. That means return n multiplication factorial n minus 1 is going to execute. So this factorial 4 is going to execute return 4 into factorial 3. So now you can see here the value of n is 3. So if n equal to 1, it is false. So the else part is going to execute. So this factorial 3 is going to execute return n multiplication factorial n minus 1, or we can say this is going to execute return 3 into factorial 2. So similarly this factorial 2 is going to execute return 2 into factorial 1. Now here in factorial 1 you can observe here the value of n is 1. So if n equal to 1, so this becomes true. So this return 1 is going to execute. So this factorial 1 is going to execute return 1. Now, so this return 1 is going to return the value of 1 to its caller, that is factorial 1. So now factorial of 1 is equal to 1. So return 2 into 1. So it is equal to 2. So this is going to return 2. So it is going to return 2. Now this factorial 2 becomes 2. So 3 into 2, that is equal to 6. So it is going to return 6. Now factorial 3 becomes 6. So 6 into 4 becomes 24. So this one is going to return 24. So in this way we are going to get the factorial of 4 is equal to 24. So factorial 4 equal to 24. In this way we are going to get. So here you can observe in the black color we are representing the return values, and in the red color we have written how the factorial 3 executes 3 into factorial 2. Similarly, how the factorial 2 executes 2 into factorial 1, like this. So it is a small example we have considered for n equal to 4. You can take any other values of n also. Now you can see the complete program here. So in the class test we have two methods. One is main method, another one is factorial method, and this factorial method we have already discussed how it works. Now in the main method we are taking a number from the user, and that number is stored in variable num, and now in factorial method the num is passed and the return value is stored in the variable n, and we are printing the value of n. So this is the complete program that uses the factorial method we have discussed. Now consider another example, that is to find the sum of first n natural numbers. That means if the value of n is equal to 5, then we want to compute 1 plus 2 plus 3 plus 4 plus 5, or we can write in this way: 5 plus 4 plus 3 plus 2 plus 1. Now if the value of n is equal to 4, then we can write this 4 plus 3 plus 2 plus 1. Now consider if the value of n is 3, so we want to compute 3 plus 2 plus 1, like this. Now assume the method name is sum. So assume the method name is sum, and we want to compute the sum of first n natural numbers. So if we generalize this 4, 3, 5 with n, so or here you can observe, we can write, so before moving to sum n, so here we can write sum of 5 is equal to 5 plus 4 plus 3 plus 2 plus 1, and this 4 plus 3 plus 2 plus 1 is equal to sum of 4, like we have written here. When the value of n is 4, it is 4 plus 3 plus 2 plus 1. So here we can write in this way: 5 plus sum of 4. Similarly, sum of 4 we can write 4 plus sum of 3. Similarly, sum of 3 we can write 3 plus sum of 2, and sum of 2 we can write 2 plus sum of 1, and sum of 1 we can write 1 plus sum of 0, and sum of 0 is equal to 0. So this is the base case, because here we know the result sum of 0 is equal to 0, and the others are recursive calls. Sum of 4, 5, 3, 2, 1. So these are recursive calls. Here we don't know the result. We are partitioning the problem into two parts. One is 4 plus sum of 3, 3 plus sum of 2. And here sum of 0 is equal to 0. We know. So this is the base case. Now we can generalize this using n. Assume sum is a method, or we can generalize sum of n equal to n plus sum of n minus 1. So using this recursive call or recursive case and base case, we can write the complete method like this. So public static int sum int n. So if n equal to 0, so we can write if n double equal to 0, we can write return 0, else we can write return n plus sum of n minus 1. Or we can write this method in a different way. We can write this method in a different way like this. So public static int sum int n, and here we can take a variable int s equal to 0, and if the value of n is 0, then s is 0. S means the sum, else the value of s or the value of sum is like this, n plus sum of n minus 1, then at the end return s. So these two are same. So here we are directly returning the value, and here we are taking another integer variable and computing the value of s, then we are returning s. So same thing. So here you can see this one, we are directly returning the value depending on the value of n, and here we are taking another variable s and computing the value of s depending on the value of n, and at the end we are returning the value of s. So you can see the complete program like this. Inside class test we have one method main method and another method sum method. So inside class test we have two methods, one is main, another one is sum, and in the main method like scanner is defined, then enter a number, num equal to ip dot next int, then result equal to sum, then num, or here the sum method is called. So when we call the sum method and pass the value of num as argument, then the control comes here or this method gets executed and s value is 0, and if n equal to 0 then s is 0, else s is equal to n plus sum of n minus 1, then return s. So this is the method we have just discussed, and this is the main method, and you can see this is the complete program. Now consider another example that we want to solve using recursion. Suppose we want to find the sum of the digits of a given integer. So let us write sum of the digits like SOD, and if I write 2, 4, 6, 5, so we can write this one like 5 plus 6 plus 4 plus 2, so 2465. So if you want to compute the sum of the digits, so it is like 5 plus 6 plus 4 plus 2, so it is equal to 5 plus 6 11 plus 4 15 plus 2 17. Now similarly sum of the digits of 246, so it is equal to 6 plus 4 plus 2, so it is equal to 12. Similarly I can write sum of the digits 24, so it is equal to 4 plus 2, so you can say it is like 6. Now sum of the digits 2, so it is equal to 2 only, because we have a single digit here, we have a single digit. The sum of the digits 2465, sum of the digits 2465, so this I can write sum of the digits 2465, so I can write like this 5 plus sum of the digits 246. So because it is 6 plus 4 plus 2, so in place of this one I can write sum of the digits 2, 4, 6 or 246. So this sum of the digits 246, so I can write this 6 plus sum of the digits 24. So here it is sum of the digits, the name of the function is SOD, or name of the method is SOD, not SUM. Similarly I can write this one sum of the digits 24 is equal to 4 plus sum of the digits 2, and sum of the digits of 2 is 2, that is already known, or when we have a single digit then we can directly get the answer. So if it is if we want to generalize this with n, then we can write sum of the digits n is equal to n modular division 10, that means the rightmost digit of n, or we can say the digit that is at the unit place of n plus sum of the digits by removing the rightmost digit of n, or by deleting the rightmost digit of n. So how to delete? So if we divide this n by 10, we are going to delete or discard the rightmost digit. So we can write sum of the digits of n is equal to n modular division 10 plus sum of the digits n by 10. So this is the recursive case. So this is the recursive call. And what is the base case here? So the base case is like this: sum of the digits when n is less than 10, that means for single digit numbers that is equal to n. So that is equal to n. So when the value of n is less than 10, so it is n, and in other case it is n modular division 10 plus the same method with simpler input, that is n by 10. So we can write these things like this. So public static int SOD int n. So if n less than 10, return n, else return n modular division 10 plus SOD n by 10. So this is the recursive method to compute the sum of the digits. So you can see the complete program. So this is the method that we have discussed. Public static int sum of digits. So here the method name is sum of digits, and we are writing SOD in short. We are using SOD. Here it is sum of digit. And if n less than 10, return n, else return n modular division 10 plus sum of digit n division 10. And this is the main method. So you are taking the input and calling the method and printing the value of result. So you can see the complete program here. Now consider another example, that is find the binary equivalent of a positive decimal number. Suppose consider 6 and we want to find the binary equivalent of 6, and we know the procedure how to compute the binary equivalent. So divide this number by 2. So 3 is the quotient and 0 is the remainder, and again divide this number 3 by 2. So 1 is the quotient and 1 is the remainder. Again divide this 1 by 2. So 0 is the quotient and 1 is the remainder. So here we find 0 is the quotient. Now we will stop, and the remainders in reverse order is the equivalent binary. So it is 1 1 0. So here you can observe we are doing the same procedure once again for 6. So first divide this 6 by 2. So 3 is the quotient, remainder is 0. Now this part is the binary representation of 3. Here you can see. So here you are getting 1 1. So it is binary representation of 3. So we can write here in place of 1 1, here we can write binary representation of 3. Similarly consider another number. Suppose you want to find the binary equivalent of 13, and we want to divide this number by 2. So 6 is the quotient, remainder is 1. So we want to add this remainder, or we want to concatenate this remainder with the binary equivalent of 6. Binary equivalent of 6, or binary representation of 6. So we want to concatenate this remainder 1 with the binary representation or binary equivalent of 6. So similarly here for 6 we want to concatenate this 0 with the binary representation of 3. and here you can observe what is the binary equivalent of 6. So it is 110. So it is 110, and for 13 it is 1101. So if we want to generalize this for any number n, we can divide this number by 2, and here the quotient I am writing q, and here the remainder I am writing r, and we want to concatenate this remainder r with the binary equivalent of q. So this one. So how to concatenate? Then how to concatenate two numbers? Suppose we have one number 5, another number is 1. So how to write 51? That means concatenate 1 with 5. So simply 5 multiplication 10 plus 1. So we are going to get 51. Similarly, suppose 3, another number is 8. So how to concatenate 8 with 3? So simply 3 into 10 plus 8. So it is 38 or 38 concatenated. So when we want to concatenate r with the binary equivalent of q, so simply we can write this one, binary equivalent of q into 10 plus r. So b I am in short I am writing. So that is binary equivalent of q into 10 plus r. We can write. So how to get the value of q, or how to get the quotient, that is n division 2, and how to get the remainder r, that is n modular division 2. So following these concepts, we can write the method like this: binary, the name of the method, and it is taking the integer parameter, it is n. Then if the value of n equal to 0, then its corresponding binary is 0. So for positive integer 0, the binary is 0. So we can write if n equal to 0, return 0, else, that means when the value of n is non-zero, so we can write else return binary n division 2 into 10 plus n modular division 2. And you can complete this one like public static int binary like this. So this is the method or recursive method that computes the binary equivalent of a positive decimal integer. So here you can see the complete program. So this is the main method. It takes a number and calls the binary method, and here the binary method as we have discussed, or like we have discussed. Now consider another problem that can be solved using the concept of recursion, and that is to print the Fibonacci sequence. Or to print the Fibonacci series. So the Fibonacci series are like this: 0, 1, then 1, then 2, then 3, then 5, then 8, then 13, then 21, then 34, like this. So here you can observe the first number is 0 and the second one is 1 and the other numbers are the sum of its previous two. So here you can add 1 plus 2, the next number is 3. 3 plus 5, it is 8. So 5 plus 8, it is 13. 13 plus 21, it is 34. So by adding two numbers, we are getting the next number. So similarly 21 plus 34, so we are going to get 55. So like this. So you can consider, so these are the numbers and the index is like this. So index is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have written up to 10 numbers. So similarly you can consider. So when the index is 0, the number is 0. When the index is 1, the number is 1. And when the index is 2, the number is 1. And when the index is 3, the number is 2. When the index is 4, the number is 3. When the index is 5, the number is 5. When the index is 6, the number is 8, like this. But here you need to remember the first two index, that is 0 and 1. So the number at 0th index is 0. The number at 1st index is, the number at first index is 1. Now except this 0 and 1, any other index number or any other number in the Fibonacci sequence we can get by adding the previous two numbers in the sequence. So if we want to write a method for this, so let the method is Fibonacci. So we can write the complete method like this: public static int Fibonacci int n. So here n is the index. So how to get the value or how to get the number at index n? So if n equal to 0, so you can write like this: if n equal to 0, then the value is 0. That means here you can see at index 0, the number is 0. Now else if n equal to 1, so return 1. So if the index is 0, return 0. If the index is 1, return 1. So here you can observe, when the index is 1, the value is 1. The index we have written in red color. Otherwise, for other values of n, so we can write else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. So here you can see the complete method Fibonacci. So it is simple one. Following this index we can write the method. So using this method you can write the complete program. So this is the complete program. So this is the method, and in the main method we are asking the value of n. That means we want to print up to nth index. Then using a loop up to n, we are passing the value of 0, 1, 2, 3, 4 like this up to n, and each time this Fibonacci int n is going to find the number at index n, and here you can observe this n and this n are different. So this n is different and this n is different. So here this value of I is passed to n when we call this method. So when I is 0, it is going to return 0. When I becomes 1, it is going to return 1. So when I becomes 2, it is going to return 0 plus 1, or it is going to call Fibonacci 1 plus Fibonacci 0, like this. So like this it is going to find or going to print the Fibonacci sequence up to nth index. So this is the complete program. Now consider another example that we can solve using the concept of recursion, that is GCD, or we can say greatest common divisor. So using Euclid's algorithm, we know that GCD of AB is equal to GCD of B and A modular division B. So for example, we can take two numbers 25 and 40. So GCD of 25 40 is equal to GCD of B, that means GCD of 40, then 25 modular division 40. So it is equal to 25. So this is equal to GCD of 25, then 40 modular division 25, so it is 15. So it is equal to GCD of 15 10. So it is equal to GCD of 10 then 5. So it is equal to GCD of 5 0. So following this formula, GCD of AB equal to GCD of B, A modular division B, we are getting these values. Now when we get this value of B as 0, then this one is the GCD. So here in this example, GCD is equal to 5. Why 5? Now because when we get this value as 0, the A value is the GCD. So if we want to write a method using this concept, then we can write like this: public static int GCD int A int B. So we are taking two numbers A and B. Now if the value of B is 0, like here, if the value of B is 0, then the GCD is A. So here we can write if B equal to 0, return A. Else means if B not equal to 0, then GCD of AB equal to GCD of B, A modular division B. So we can write return GCD of B, A modular division B. So simple one. So this is the method to compute GCD of two numbers. Now using this method, we can compute or we can find the GCD of two numbers. So here you can see the complete program. So this is the main method and this is the GCD method we have just discussed. Now in the main method, we are taking two integer values, num1 and num2, and we are calling the GCD method GCD num1 num2. Now when we call this GCD num1 num2, the value of num1 is passed to A, the value of num2 is passed to B, and recursively this method computes the GCD and returns the value of GCD to this result. Now we are printing the result value. So this is the complete program using recursive method to find the GCD.